My name is Leon Eckert, and my thesis is called Biometric Intimacy. To start off, I want you to think of a person you know really well. Maybe your best friend, maybe your partner, or perhaps a sibling. The better we know a person, the more literate we become in reading them. We develop an intuitive sense for their feeling, and guided by the sense, we ask questions like, "Are you fine?" or "Did anything happen?" Their usual behavior is so familiar to us that we notice subtle shifts that are invisible to most other people. Another relationship the majority of us engages in is the one with our devices. We carry them around with us at all times, and we share the most intimate moments with our phones and computers. In their own way, they know us really well too. Similar to how our thoughts and feelings are reflected in the way we move and talk, they must somehow be reflected in the way we use technology as well. And I'm wondering if, just how we have a sense for the well-being of the people around us, can our devices detect subtle variations in the way we interact with them? Asked differently, by analyzing the rhythm of my keystrokes, can a machine learning algorithm make guesses about my mental state? That is the question that I started to explore 3 months ago, and I will now talk you through my research so far. To start off though, let's roll back a little bit. Over the last 2 years, I've mostly thought about issues of privacy, surveillance, and security. And this is also what brought me to this subject, as of course, finding things about me by analyzing the rhythm of my keystrokes is concerning, and people should know. However, one of the main things I learned is that a dystopian perspective on these subjects, like you see here, might be a natural one, but it definitely isn't a very effective one if you want people to actually listen to you. Instead, I have to start with myself and ask, why do I engage and what keeps me listening, and then go from there. The things that are being done out there with technology and in regards to our privacy are nuts. And by that I mean they're, on a technical level, really fascinating. Analyzing my keystrokes in order to make assumptions about how I feel sounds really exciting to me, and my strategy is to share this excitement. I'm not the first person to research this question, but perhaps I can be the first to explore and, more importantly, present my findings in a way that they have not been presented before. My goal is to make them digestible to an audience other than scientists reading and writing white papers. Let's move on. My thesis is about biometrics. Biometrics describe physiological and behavioral characteristics of humans, such as fingerprints or walking gait. When interacting with technology, we're producing behavioral information too. I'm concentrating on keystroke dynamics, the study of keystroke patterns. The way these patterns are studied is as follows. As you hit the keys, writing the word ITP, for example, there's 3 data points on each keystroke. The key value itself, the time when the key is pressed, and the time when the key is released. To study the actual rhythm, researchers and myself are looking at the so-called dwell time, the duration between the key press and the key release of one key, and the flight time, the interval between the key press of one key and the key press of the next. Studying this, there's 2 main things to learn. First, if you type a word and your friend types the same, the rhythm will be different. And second, over time, our rhythm is generally consistent. This is not new, and it's already in use, most prominently as an authentication mechanism. During the process of my project, I built this app to demonstrate just that. The app has 2 modes, enroll and test. In the enroll mode, the user gives his or her name, followed by typing a specific piece of text. Then in test mode, anyone can type into the app, and the algorithm running it calculates whose typing rhythm is matched closest in order to make a prediction of the identity of the typist. I was really surprised how well these guesses were, especially given that there was very little data input needed. And also because the method of analysis that is being used here is purely statistical, meaning it's comparing average dwell and flight time, the 2 concepts you guys just learned about. To achieve better results, machine learning seems a good approach, and here's why. Machine learning is great for finding patterns in labeled data, or in this context, finding a correlation between a specific typing rhythm and a person. This knowledge can then be used to make more accurate guesses on typing patterns that the algorithm has not seen before. To make a learning process successful, however, you have to prepare your data, and like a good teacher, expose its most characteristic features and then carefully feed them into your algorithm. To do that, I installed a script on the computers of 10 friends of mine, logging the key value, the press and release time of every keystroke they would do with a nanosecond precision. These programs ran for 1 to 3 months. Next, I analyzed this data, looking for 2 things: consistency and separability. What I found is that different key combinations score better or worse in these 2 aspects, making them more or less suited as a base for guesses. To illustrate that better, take a look at this graph showing the transitions from the key P to Y, as in the word pyramid, for example, and all the instances in which my friend Chino in blue and myself in red typed these 2 keys. Again, they're plotted by dwell and flight time. What is obvious from the graph is that Chino and I are consistently typing these 2 keys in different rhythms. And it suggests that if you wanted to verify mine or Chino's identity, you could potentially make us type the word pyramid and analyze our keystroke rhythms to make a really good guess over who is who. To use what I learned here in my machine learning explorations, I took the top 20 most separable such key transitions and fed them into my machine learning algorithm. To make up for different amounts of recorded data points, I generated a lot of fake data with the same distribution. That way, my algorithm achieved 85% accuracy in its guesses, which is not yet as good as I hope, but I'm confident to have further breakthroughs on this in the near future. This is a good time to remind of the actual interest I'm after here, which is finding a correlation between keystroke pattern and mental state. How does my typing differ when I'm tired, intoxicated, or heartbroken? What I've talked about so far mainly dealt with identifying individuals. But really, I see identity as a research proxy here, with the hope being that once I'm able to correlate a typing pattern to the name of a person out of a group of people with high accuracy, then I should be able to correlate subtler variations within a typing pattern to the mental states of a single person with at least some accuracy. By now, some of you must be asking, what do I even mean by mental state, and how would I possibly collect it? Isn't that a completely subjective thing anyway? And my answer would be that yes, it is, and the only way I can think of, and therefore my best bet, is to collect mental states through self-reporting. To do that, I built a 4-step framework that I will be using over the coming months, and hopefully other people will too, to collect and process data. I will now walk you through how this framework works. A keylogger runs in the background, collecting information about every keystroke I make. If my typing input increases, a pop-up window is activated, asking me to quickly and by gut feeling rate a number of tags that are defined at the start. It then attaches the ratings to the keystroke information. When a good amount of data has been collected, it is fed into a machine learning algorithm that is training a model trying to correlate typing pattern to tag intensity. As an example, you can think of my typing rhythm likely to become slower when the tag tired is rated high. Or maybe I'm using the backspace much more often if intoxicated is on a score of 10. The trained model is finally used back on the user side to make real-time predictions as the keyboard is used. Over time and with more data, these predictions should hopefully become more and more accurate. For now, I don't have a definite answer to my thesis question, but I became extremely familiar with the subject and brought all the bits and tools into place to formulate an answer. To close, I'd like to get back to the analogy that I opened with and add one more thought. The relationship we engage in with our devices is intense. Moreover, we should bear in mind that it is a one-directed one, meaning we open ourselves up to our devices, not the other way around. And with that comes vulnerability. That is in contrast to human relationships, where intimacy is mutual. The same vulnerabilities exist, but as they are shared, they create ground for trust and facilitate empathy. A very good example for this is the community that I was so incredibly lucky to be a part of myself here at ITP over the last 2 years. And that's why I want to end by saying thank you to all the people that helped and loved me so much.